Hello everyone, I am Mauli Raj, Assistant Professor, Department of Computer Science and Engineering, Sri Shanmuga College of Engineering and Technology, Salem. Today we have see about Introduction to Data Structure. What is mean by data structures? We have know about the linear data structures and non-linear data structures, also primitive data types and non-primitive data types. Okay, we have see about the first topics list the 1.1 abstract data types, ADTs. What is mean by ADT? ADT means modular programming. The basic rule of programming is that no routine should ever exceed a page. This is accomplished by breaking the program down into modules. Each module is logical unit and does a specific job. What are the advantages of modular programming? Easier to debug routines, easier for several people to work on modular programming simultaneously. Making changes in modules are easier. Abstract data types definitions. And abstract data types ADT or mathematical abstraction for the data types where a data type is defined by its behavior from the point of view of a user. Examples: list, stack, queue, hash tables. What is mean by list? List is the linear data structure. Under the list is there are three types: single linked list, double linked list, and circular linked list. Stack means last in first outs. Queue means first in first outs. Okay, what is data structure? Data structure is a way of storing, organizing, and retrieving data in a computer so that it can be used efficiently. It provides a way to manage large amounts of data efficiently. This is the diagram for a classification of data structures. Data structures under the primitive data structures and non-primitive data structures. What are the types under the primitive data structures? Means integer, float, and string. Non-primitive data structures under linear data structures and non-linear data structures. What are the topics covered in linear data structures? Linear data structures covered three types: list, stack, and queue. What are the non-linear data structures types? Tree and graphs. Tree means you have used a binary tree, yeah, red black tree. Graph means you have used various types of graphs, connected graph, unconnected graph, and some traversals also used in this graph methods. Next, primitive data structures. What is the primitive data structures? It is a basic data structure. It is directly operated upon machine instructions. Example: int, char, float. What are the non-primitive data structure? There are derived from the primitive data structure. It defines the group of homogeneous and non-homogeneous data items. Examples are array, list, graphs, tree, etc. Linear data structures. What is the linear what is the linear data structure? In linear data structure, the data are arranged in linear order. Examples are array, linked list, stack, and queues. Non-linear data structure. What is mean by non-linear data structure? The non-linear data structures data are arranged in hierarchical order. Examples: trees and graphs. Next, 1.2 list ADT. List is a linear collection of data items. The general form of list is A1, A2, A3, A3, up to AN, where n equal to size of the list. A1 is the first element of the list. AN is the last element of list. A list of list zero element is called empty list. For any list, the element at the position I is AI, then AI plus 1 follows, succeeds AI, and AI minus 1 proceeds AI. Okay, next, operations performed on the list are insert x comma p, insert the element x after the position p. Example: insert x comma 4 means the example value is 36, 23, 49, 53, 12, 98 will be 36, 23, 49, 53 x comma 12 comma 98. X means you have insert the new node name is x. The delete element x from the list means the delete example we have assumed the 12. Okay, the example value is 36, 23, 49, 53 x comma 12 comma 98 will be 36, 23, 49, 53 x, and the 12, the no 12 is deleted. So we have moved to 98. Find the x, return the position of x. Next I return the position of successor element I plus 1. Previous I equal to I returns the position of its procedures elements I minus 1. Print the list, print the element of the list. Okay, implementation of list ADT. List can be implemented in three ways. There are array based implementation, linked list implementation, and cursor based implementation. What is mean by array based implementation? The simplest way of representing a list is using an array. It is an ordered collection of elements stored in continuous memory locations. Example 36, 23, 49, 52, 12 can be represented as a array. Means the 36 means we have used examples you have used 5 values 36, 23, 49, 52, 12. We have normally used means 1, 2, 3, 4, 5. We have take the values, the 5 values. Okay, but the index value means we have assumed the index value 0. Example, the 5 values means we have used to 0 to 4. 0 to 4 means we have used the 5 values. Okay, 36 means a of 1, 23 a of 2, 49 a of 3, 52 a of 4, 12 means a of 5. A of means array of 1, array of 2, array of 3, array of 4, array of 5. Up to the 5 elements the calculated based on array based implementation. Next, what operations? What are the operations used in array based implementation? Insertion, deletion. This is the basic operation. Insertion is the process of adding an element into existing list. It can be done at any position. Insertion at position 0 requires pushing the entire array down one position to make a room for the new element. The example list, the list I have take the 5 values, but the index value is 0 to 4. List 0, list 1, list 2, list 3, list 4 is empty. Okay, the list 0 is 5, list 1 is 10, list 2 is 23, list 3 is 62. Okay, I have insert the new values. Third position I have insert the 2. Third position I insert the value 2. It will be insert element 3 after the position 2. Step 1, the index value. The index value means index value is 0. The list, the first value is 5. 0, index 0 is 5, 1 is 10. The index list 2. List 2 is the third position. I have third position. I have insert the 2 values. So I have insert the third position 2 after list 3, 23rd, and list 4 is 64. The position wise I have third position, insert the value 2. The step 2 is 5, 10, 3, 23 and 62. Okay, this is the example program of routine for position for I equal to n minus 1, I greater than equal to position I minus minus. List of I plus 1 equal to list of I, list of position equal to item. Next we have see about the deletion. Deletion is the process of removing an element from the array at any position. Deleting at position 0 requires shifting all the elements one position up. This is the examples of deletion. First we have need the 5 values. I have already fixed in 4 values. List 0, 1, 2, 3, list 4 is empty. Okay, the index, this is also we have used index value. Index means 0 to 4. I have 5 values, but we have take the index value means 0 to 4. Okay, delete 23, it will delete the element 23. Means the what are the what way we have delete. We have see about the next diagram. Step 1, index list, list 0 to 4 I have already assumed. The third position list 2 and third position I have fixed the 23 values, but I have removed the element 23 at the third position. Okay, the shadow position is the delete third position list 2, remove the element 23. I have removed the element 23. The remove means I have shadowed the diagrams. Step 2 I have removed the 23, so automatically third position deleted. So I have 5, 10 and 62. Shift the element from fourth position to third position. The 62 is the fourth position. The 23 is the third position. 23 deleted means 62 is shifted to third position. Okay, this is the step 2 explanation. 5, 10 and 62. Next, this is the example program for I equal to position I less than n minus 1, I plus plus list of I equal to list of I plus 1. Merging two started list. This is the example diagram of two started list. Okay, this is the example program. You have refer it. Next, print list. Print list is a traversal. Traversal is the process of listing the element in an any array. It is used to display the element of the array. This is the example program. The find traversal and find, it is used to search any element in the list, and it is also the same example program for the find the element in the nodes. Okay, next we have see about the linked list implementation. What is the linked list implementation? The linked list is consist of series of nodes which are not necessarily adjacent in memory. Each structure consists of two parts, the element and pointer to the next node. This is the example diagram for the linked list implementation. First node is the data element, next node is the next pointer. The pointer is called the next pointer. The last cell next pointer point to the null. The pointer variable contains the address where some other data are stored. The general form of linked list. This is the general way of linked list. The diagram is A1 point to the A2, A2 point to the A3, A3 point to the A4, A5 point to the null values. Okay, representation of linked list which actual values A1 800, A2 700, A3 600, A4 500, A5 500. The last value is null. This is the linked list with actual pointer values. Okay, the list of contains 5 nodes that reside in memory locations 1000, 800, 700, 600 and 500. The next pointer in the first node contains the address of second node. Example 800. There are 3 types of linked list: single linked list, double linked list, circular linked list. Okay, we will see about the detailed explanation in particular linked list explanation. We have move about the 1.5 single linked list. A single linked list consists of series of nodes. They are not necessarily adjacent in memory. Each node in the single linked list contains the data and only one pointer to the next node. Structure of a node is, this is the structure: A1 linked to A2, A2 linked to A3, A4 linked to A5. Actual representation, I have fixed the A1 some value, A2 some value, A3 some values. The A1 memory location is 1000, A2 is 800. Okay, this is the operation performed in linked list: insertion, deletion. Okay, the first one is insertion. I have insert the value in A2 between A3. Okay, A2 A3 link is the first cut. Next we have insert the new node. New node means the X. Okay, create a new cell from the system using malloc cell. Execute 2 pointer changes. Next we have deletion: A1, A2, A3, A4, A5. Execute the 1 pointer change. Delete the cell using free command. Okay. Next we have print list L. Find the L comma key. Pass pointer to the key to the first element in the list, and then traverse the list by following the next pointers. Find k L comma I takes OI of time. Header node, sentinel node or dummy node. Okay, in linked list problems occur in various sections: insertion at the front of the list, a deletion at the front of the list, a deletion in general. All this situation requires us to keep track of the cell before we want to delete. To solve the problems, we will keep the sentinel node or header node. So after deleting the first element in the list, find the previous will return the position of the header. Okay, routine creating a node structure: struct node, element, type of element, position next. This is the is empty. Empty, the empty node mean the this function is used to check whether the list is empty or not. In is empty list L, return L, the next null. This is the return will return one value if the list is empty. Okay, is lost, the function is used to check whether the current position is the last position in the linked list. The node is last position. We have checked whether this general terms, and this is the example diagrams. This is the find the node. The function is used to find the element. X in the list. Position, find the element type. X is list L. There is an example program and the example diagram.